making formula of compounds and producing formula of the compounds from constituent ions. When we know the name and valency of some ions, it is possible to assign formula of compounds. So it's a very easy method to remember and write the formula of many compounds. First of all, we are going to study some ions. You know, there are two types of ions, namely cations and anions. Cations are positively charged ions and anions are negatively charged ions. I'm going to give you some examples of cations and anions. You have to study all these ions together with their valencies. Then from these ions and their valencies you can assign, or you can write, or you can remember the formula of many compounds, and therefore you can easily write the equations from these ions. Okay. Ions. They may be cations or anions. Formulae. Formulae or formulas. Formulae or formulas and valency. Hydrogen ion, Hydrogen, hydrogen ion. You know that hydrogen ion is produced by removing a electron from hydrogen atom. So H plus, and its valency is 1. Now hydride ion, HydRide, it's the negatively charged ion formed from hydrogen by adding an electron to hydrogen, that is H minus, its valency is 1. This is hydrogen ion, positively charged ion, and this is hydride ion, negatively charged ion. Now sodium ion. Sodium ion, Na plus, its valency is 1. Lithium ion, LiThium, Li plus, its valency is 1. Potassium ion, K plus, its valency is 1. Calcium ion, Ca2 plus, its valency is 2. Magnesium ion, Mg2 plus, its valency is 2. Barium ion, barium, Ba2 plus, its valency is 2. Aluminium ion, Al3 plus, its valency is 3. Nitride ion, nitride ion, N3 minus. See, it's obtained by adding 3 electrons to a nitrogen atom. So N3 minus, that is nitride ion. So its valency is 3. Then phosphide ion, PHOS, PHIDE. It's also obtained by adding 3 electrons to a phosphorus atom. That is P3. Its valency is 3. Fluoride ion, FluorIDE. F single minus, its valency is 1. Chloride ion, CHLORIDE, chloride ion. Cl minus, its valency is 1. Bromide ion, BROMIDE, bromide ion. Br minus, its valency is 1. Iodide ion, IODIDE. I minus, its valency is 1. Oxide ion, O2 minus, valency is 2. It's obtained by adding 2 electrons to an oxygen atom. Now peroxide ion, PROXIDE, peroxide ion, O2, 2 minus. See, hydrogen peroxide, you know, HOOH, that is H2O2. If 2 hydrogen ions are removed, H plus ions are removed, we get remaining part as O2, 2 minus, that is O2, 2 minus. O2, 2 minus. So peroxide ion is O2, 2 minus, its valency is 2. 2 oxygen atoms capture or acquire 2 negative charges. So peroxide ion has the valency 2. Then another oxide ion is, oxygen carrying ion is superoxide. See, O2 single minus, valency is 1. It's superoxide. Its valency is 1. Sulfide ion, SULPHID, sulfide ion, S2 minus, its valency is 2. Ferrous ion, FeRrous, ferrous, Fe2 plus, valency is 2. Ferric, 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 Fe3 plus, valency is 3. Cuprous, 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 Cu single plus, valency is 1. Cupric, CuPric, Cu2 plus, valency is 2. Chromium, 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 Cr3 plus, valency is 3. Manganese, 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 Mn2 plus, valency is 2. Zinc, 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 Zn2 plus, valency is 2. Mercurous, Hg single plus, valency is 1. Mercuric, Hg2 plus, valency is 2. Mercuric, Hg2 plus, valency is 2. Then ammonium, 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 NH4 plus, valency is 1. You know, ammonia is NH3. If a hydrogen ion is added to ammonia, we get ammonium ion, NH4 plus. This is ammonium, this is ammonia. So ammonium ion is NH4 plus. Now nitrate, NO3 single minus, valency is 1. See, nitric acid is HNO3. If a hydrogen ion is removed, H plus ion is removed from nitric acid, we get NO3 single minus. That is what is called a nitrate. It ends with ATE. Now, nitrite, NO2 single minus, valency is 1. Nitrous acid is HNO2, nitrous acid. This is ic acid and this is us acid. If a H plus ion is removed, if a hydrogen ion is removed, we get nitrite ion, NO2 minus, NO2 single minus. So, nitrate is formed from ic acid and nitrite is formed from us acid. And you know that nitride is N3 minus. This is nitride. Okay. Now, sulfate, SULPHATE, sulfate, SO4 2 minus. Valency is 2. See, sulfuric acid is H2SO4. When both the hydrogen ions are removed, H plus ions are removed from sulfuric acid, we get sulfate. Now, if only one hydrogen ion is removed, then HSO4 single minus remains. It is called bisulfate or hydrogen sulfate. HSO4 single minus, valency is 1. Now, you know that sulfurous acid is H2SO3. If both the hydrogen ions are removed from sulfurous acid, that is, if two hydrogen ions are removed from sulfurous acid, you get SO3 2 minus. That ion is called sulfite. SO3 2 minus. See, this is sulfate. It is obtained from ic acid. Now, this is sulfite. It is obtained from us acid. Okay, its valency is 2. If only one hydrogen ion is removed from sulfuric acid, we get HSO3 single minus. It is called HSO3 single minus. It is called bisulfite. See, bisulfite, its valency is 1. See, this is sulfate, SO4 2 minus. This is sulfite, SO3 2 minus. This is hydrogen sulfate, HSO4 single minus. This is bisulfite, HSO3 single minus. Bisulfite or hydrogen sulfite, HSO3 single minus. Cyanide, CYANIDE. Cn single minus, valency is 1. Cyanate, CYANATE. CNO single minus, valency is 1. This is cyanide and this is cyanate. Okay. Acid ion, AZID, azide ion, N3 single minus. See, 3 nitrogen atoms are there with a single negative charge. See, this is what is called azide ion. Its valency is 1. Now, acetate ion, ACETAT, acetate ion. You know that acetic acid is CS3COOH. This is acetic acid. If H plus ion is removed from acetic acid, we get a negatively charged ion called acetate. This is acetate ion and its valency is 1. Now, formate ion, FORMAT. You know that formic acid is HCOO, H single bond COOH. This is formic acid. If one hydrogen ion is removed, we get HCOO single minus. Its valency is 1. This ion is called formate. Now, oxalate ion. You know that COOH single bond COOH. It is a dicarboxylic acid. It is the simplest dicarboxylic acid. If 2 hydrogen ions are removed, if 2 hydrogen atoms are removed, we get a double negatively charged ion called oxalate. See, its formula is C2O4 2 minus. This ion is called oxalate. Its valency is 2. Now, another ion is permanganate, PERMANGANATE, permanganate. MnO4 single minus. Its valency is 1. This is what is called a permanganate. Now, manganate is MnGANATE. Manganate is MnO4 2 minus. Its valency is 2. This is manganate. See, MnO4 single minus is permanganate with a valency 1. MnO4 2 minus is manganate with a valency 2. Now, chlorate, CHLORATE, not chloride. Chloride is Cl minus. This is chlorate. ClO3 single minus. Its valency is 1. Chlorite, CHLORITE. See, ClO2 single minus. Its valency is 1. So, ATE become ITE by reducing one oxygen atom. See, here one oxygen atom is less, but charges remains the same. This is chlorate, ends with ATE, and this is chlorite, ends with ITE, ClO2 single minus. And if one oxygen atom is also reduced, then, or one oxygen atom is further reduced, then we get ClO single minus. It is hypo. Prefixing hypo means lower than that. Hypochlorite, CHLORITE. See, it is lower than chlorite, means one oxygen atom is less than that of chlorite. That is ClO single minus. It is what is called a hypochlorite. Hypochlorite. Okay, valency is 1. Now, perchlorate, 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 ClO4 single minus, valency is 1. See, chlorate is ClO3 single minus, its valency is 1. Now, when one oxygen atom is increased, one oxygen atom is raised, one oxygen atom is increased, we get ClO4 single minus. That is what is called perchlorate. Its valency is also 1. So chlorate, chlorite, hypochlorite and perchlorate. Now ferrocyanide, 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 FeCN 6 times. It's a complex ion with 1 iron atom and 6 cyanide ions. That is FeCN 6 times. Its valency is 4 minus and valency is 4. Now ferricyanide, FeRrICYANide, it is FeCN 6 times 3 minus, its valency is 3. This is ferrocyanide and this is ferricyanide. Now thiosulfate, THIOSULPHATE, thiosulfate, you know that it is S2O3 2 minus, its valency is 2. Thiosulfate. Now carbonate, you know that CO3 2 minus, its valency is 2. And bicarbonate is HCO3 single minus. By adding a hydrogen ion to carbonate ion, one negative charge gets cancelled, so we get HCO3 single minus. It's called a bicarbonate. Its valency is 1. Similarly, you can add ions as many as possible. You have to add and study those ions. If we know the formulae and valency of these ions, it is possible to write or remember the formulae of ionic compounds. Let us see an example. See, aluminium sulfate. How can we write the formula of aluminium sulfate without errors? See, aluminium, remember aluminium ion. Aluminium ion is Al3 plus. Sulfate ion is SO4 2 minus. Now, the charge of sulfate ion is crossed to the subscript of aluminium. And the charge of aluminium ion is crossed to the subscript of sulfate ion. So, we get Al2. The subscript of aluminium is 2. And the subscript of sulfate is SO4 is 3. So, the formula of the compound is Al2SO4 thrice. In similar manner, you can write a large number of formulae from some names and valencies of ions. Okay. Now, ferric sulfate, FeRrICSULPHATE, ferric sulfate. You know, Fe3 plus is ferric. Sulfate is SO4 2 minus. See, crossing their valencies like this, that is Fe. The subscript of Fe is this 2. That is the charge of SO4. Fe2. And SO4 gets the subscript of the charge of iron, that is 3. So we get 3. Fe2SO4 thrice. Crossing their valencies, we get the formula. Now, calcium oxide, CaLCium, Oxide, calcium oxide. You know, calcium is Ca2 plus, oxide is O2 minus. Crossing their valencies like this, we get Ca2. C2 become the subscript of calcium, and this 2 also become the subscript of oxygen, Ca2O2. So they can be divided by 2, we get CaO. So the formula of calcium oxide, that is quicklime, is CaO. Now, calcium nitride, CaLCium, calcium nitride, NITRIDE. See, calcium is Ca2 plus, nitride ion is N3 minus. Crossing their valencies like this, we get Ca, the subscript of Ca become 3, the charge of sodium, nitrogen, and the subscript of nitrogen become the charge of calcium, that is 2. So the formula of calcium nitride is Ca3N2. Let us check what is the formula of calcium azide. See, calcium azide, CalCium, azide, AZIDE. You know, calcium is Ca2 plus. Azide ion is N3 single minus. You know that azide ion is N3 single minus. We have already learned. See, the valency of calcium and azide ion are crossed like this. So we get Ca1 N3 twice. Ca(N3) twice. So it becomes Ca(N3) twice. That is what is called calcium azide. Calcium azide. Okay. Now let us check what is calcium nitrate. CalCium, calcium nitrate. See, calcium you know Ca2 plus, nitrate you know NO3 single minus. Crossing their valencies, we get Ca1 NO3 twice, crossing their valencies. So it becomes CaNO3 twice. Now potassium POTASSIUM, ferrocyanide FeRrOCYANIDE, potassium ferrocyanide. It's a complex. See, potassium is K plus. Ferrocyanide is FeCN 6 times the whole 4 minus. See, the charge of ferrocyanide ion is 4 and the charge of K plus is 1. Crossing their valencies like this. See, so K4 FeCN 6 times 1 times. So we get K4 FeCN 6 times. See, put this in a square brackets. Why? Because it's a complex part. This is a coordination complex that we will learn. Okay. Calcium phosphate, CalCium, phosphate, PHOS, PHATE. See, calcium, you know that valency is 2. Phosphate, PO4 3 minus. This is phosphate. It is also called orthophosphate. You can add this ion to the list. Okay. See, crossing their valencies, we get Ca. See, 3 become the subscript of calcium, Ca3, PO4, the whole twice. So Ca3, PO4 twice. This is calcium phosphate or calcium orthophosphate. Now what is calcium phosphide? CalCium, calcium phosphide, PHOS, PHIDE, calcium phosphide. Calcium, you know that Ca2 plus. Phosphide ion is P3 minus. Crossing their valencies like this, we get Ca3. See, 3 becomes the subscript of calcium and the charge 2 plus of calcium becomes the subscript of phosphorus. So Ca3P2. This is calcium phosphide. This is calcium phosphate. This is calcium phosphate. This is calcium phosphide. Now, what is lead acetate? LEAD, acetate, ACETATE, lead acetate. You know, Pb2 plus is lead. Acetate ion is CH3, single bond, COO minus. Crossing their valencies like this. See, we get Pb, CH3, single bond, COO twice. See, Pb, CH3, COO twice. It can also be written like this. CH3, single bond COO, twice Pb. Both are right. Splitting the formula of an ionic compound into constituent ions. We can split up the formula of an ionic compound into constituent ions. This is very important in the case of certain branches of chemistry like electrochemistry, chemical equilibrium, etc. Let us see how can we split up the formula of an ionic compound. I am going to give you an example. Ammonium sulphate, NH4 twice SO4. See, you know the formula of ammonium sulphate is NH4 twice SO4. It contains two parts. One is cationic part, that is positively charged part, and the other part is anionic part or negatively charged part. See, the cationic part in this formula is NH4 and anionic part in this formula is SO4. Now, splitting is the reverse process of valency crossing. See, there is one SO4 unit and there are two NH4 units. See, the subscript 2 comes here as the charge of sulphate and the subscript 1 comes here as the charge of ammonium. And you know that there are two ammonium units, that is two NH4 units are there. Two NH4 units are there and one SO4 unit is there. Okay. Now, what is the charge of NH4 unit? It is the subscript of SO4 unit, that is 1. So, it is single plus, 1 plus. Now, what is the charge of SO4? It is the subscript of NH4, that is 2. So, 2 minus. Now, let us check. Let us check whether the charges get balanced, 2 positive and 2 negative. So, the charges get balanced and the splitting is right. Now, let us check another example. PBS, you know, it is lead sulfide. It contains the cationic part Pb and anionic part S. And you know that there is one Pb and one S. So, one Pb and one S are there. What is the charge of Pb? It's plus because the subscript is 1. And what is the charge of sulfur? It is also 1 because the subscript of lead is 1. So, minus. But we know that the charge of Pb is, that is lead ion is Pb2 plus. Actual charge is Pb2 plus. And the actual charge of sulfur is S2 minus. S2 minus. So, when we split PBS, the constituent ions are Pb2 plus and S2 minus. What happened here is that while crossing the valencies during the formation of the ionic compound like this, say Pb2, S2, we have cancelled 2 by dividing the whole by 2, that is PBS. So, PBS was formed by dividing the number of lead and sulfide ions by 2. While splitting PBS, they were regenerated. They must be regenerated and not like this, but like this. It's very important. Let us check another example. CaCO3, it's calcium carbonate. See, there is one calcium and one CO3 unit. While crossing their subscripts, one Ca is there and one CO3 is there. So we put one positive and one negative here. But actually, the valency of calcium is 2 plus and the valency of carbonate is 2 minus. So CaCO3. So CaCO3 gives Ca2 plus CO3 2 minus. Lead acetate PbCS3 single bond to COO twice. This is lead acetate. See, it can be split as follows. There is one lead Pb and there are two CS3 single bond to COO units. So 2 CS3 COO. Now, what is the charge of CS3 COO unit? It is the count of Pb. Count or number of Pb. There is only one Pb, so single negative. And what is the charge of lead? It is the count of acetate ion, that is CS3 COO unit. It is 2. So Pb2 plus. Let us check whether the charges are cancelled. 2 plus 2 negative. So the charges get cancelled. So lead acetate can be split up into a Pb2 plus ion and 2 acetate ions. Now, ferric ferrocyanide Fe4, FeCN 6 times thrice. This is ferric ferrocyanide. It's a complex, coordination complex. Now, how can we split this? See, there are 4 Fe. So, 4 Fe plus there are 3 FeCN 6 times units. There are 3 FeCN 6 times units. So 3 FeCN 6 times. Now, what is the charge of Fe? That must be the subscript of this unit. That is 3. So that is 3 plus. And what is the charge of FeCN 6 times? It is 4 negative. So 4 negative. See, this come here as 4 negative and this come here as 4 negative and this come here as 3 negative. And you must remember the counts or the number of Fe 4 and the number of FeCN 6 times unit is 3. So 4 Fe3 plus 3 FeCN 6 times 4 minus. Let us check whether the charges are cancelled. 4 into 3, 12 positive and 3 into 4, 12 negative. So the charges get cancelled. Now, let us check another example. MgNO3 twice. See, this is magnesium nitrate. Here, cationic unit is Mg and anionic unit is NO3. And you know that there is one Mg unit and there are two NO3 units. Okay. Now what are the charges of Mg and NO3? See, the charge of Mg is the subscript of NO3 unit, that is 2. So 2 positive. And what is the charge of NO3? It is the subscript of Mg unit, that is 1. So it comes as 1. So it can be split like this, Mg2 plus 2 NO3 minus. Let us check whether the charges are cancelled. See, 2 positive, 2 into 1, 2 negative. So the charges get cancelled and the equation is split up into constituent ions.